Okay, today we're going to pick up kind of where we left off. We're going to talk about ions. So go ahead and write this down. Ion, an atom with a charge. Ion is an atom with a charge. Okay, so now we talked about protons having a positive charge, neutrons having a neutral, no charge, and then electrons having a negative charge. Most atoms want to be all even, okay? So if we're talking about hydrogen, hydrogen has one positive proton in it, okay? So to cancel that out, it wants one negative electron, and now it has no charge. Everything's even and good. Well, sometimes that doesn't happen, and when that doesn't happen, we call that atom an ion, okay? So an example, if hydrogen has one positive proton, if it had no electrons, let's say something stole its electron, so it has a positive and no negatives, we would call that a positively charged ion of hydrogen. So it has a charge, and it would be a positive charge because it has one positive proton and no negative electrons. On the other hand, if hydrogen has one positive proton, and let's say it has two negative electrons, so now it has one positive and two negatives, and we would call that a negatively charged ion of hydrogen. Okay, so if it has more or less electrons than it's supposed to, we call it an ion. If it has more negatives, we say it's a negatively charged, or if it has less electrons, we would call it positively charged. Hopefully that is clear, makes sense. Element, I'll take a moment, write this down. A specific type of atom that has a certain number of protons. A certain type of atom that has a certain number of protons. So I use hydrogen as an example because it's 1 on the periodic table. Any atom that has one proton is hydrogen. So if you found a random atom and you saw it had one proton, if that was possible, you'd say, oh, this is hydrogen. Or if you saw two, oh, of course, this is helium. Okay? If I changed the number of protons, I changed the element. You can't just add a proton. Okay? If you could, if you added a proton to hydrogen, then it would be helium. So the number of protons tells us what type of element it is. There's this thing called the atomic number, which tells us just that. Take a moment and write this down. Atomic number, the number of protons in an atom. This number tells us what element the atom is. So the atomic number tells us how many protons is in an atom. The periodic table is organized by atomic number. So the atomic number of hydrogen is 1 because it has one proton. Helium is 2 because it has two protons. Lithium, 3, and so on. So I could quiz you if you had a periodic table in front of you, and I could say, what element has the atomic number of 8? And you would look and see what number 8 is, and you'd say, oh, oxygen. Oxygen has 8 protons. Mass number, on the other hand, and go ahead and write all of this down, please. Mass number is the number that shows the mass of the atoms. If you find the mass of something, you're looking for like the weight. It's measured in atomic mass units, or AMUs. So instead of measuring, you couldn't measure atoms in pounds because it's not nearly big enough, or ounces or grams. They use AMUs, or atomic mass units. So on the periodic table, you're going to see that there's a decimal number on most of them. So like hydrogen, its atomic number is 1, but its mass number is 1.01, rounded off. Okay? That is the mass number. That is the weight of that atom. go ahead and write this down. To find the mass number, you must add the number of protons plus neutrons. So hydrogen is number 1 on the periodic table. It has 1 proton, 0 neutrons, so its mass number is 1. A 1 point something something, we'll get to that. Helium has 2 protons, 2 neutrons, so its mass number is 4. 4.04, whatever. So the mass number is how many things are in the nucleus, basically, which is protons and neutrons. Okay, so we just kind of don't really write anything here, but electrons, we kind of forget about them since they're so tiny. We don't worry about them with the mass. Thought this was kind of a cool illustration here. Okay, a neutron is slightly heavier than a proton, but it's close. We kind of count it as the same. Electrons, you see, are way, way smaller than protons. Isotope. Take a moment, write this down. Atoms of the same element, but with different numbers of neutrons. Atoms of the same element, but with different numbers of neutrons. So let's use hydrogen again as an example. Hydrogen always has 1 proton. Most of the time it has 0 neutrons, so its mass number would be 1. Okay, protons plus neutrons equals mass number, so it'd be 1. Every once in a while there's this weird thing called an isotope of hydrogen that has a neutron. So that's what brings, it's kind of an average, it brings the average up. So most hydrogen has no neutrons, but every once in a while there's this weird type called an isotope that has one. And that's why it brings the average, if you look in the periodic table, to 1.01, because it's an average. And most of them don't have a neutron, but every once in a while there's one that does. Same with helium. Helium has 2 protons and 2 neutrons, almost every atom. But once in a while, there's one with an extra neutron, which brings it up to 4.04. Okay? Those are called isotopes, when they don't have the amount of neutrons that they're supposed to have. So I used hydrogen. All right, so hopefully that makes sense, and if you have questions, let me know.